teaching sound synthesis in C, C++ on the Raspberry Pi, so we are all wondering how to do that, so it's good that you can make this talk. So, floor is yours.
Thanks. Basically, I'm doing this on behalf of Henrik von Koller and myself, because Henrik has some obligations with the AES in the next week, so he can't be here. And well, this is more of a recap, basically, of what we did in the last semester. We started a course for, well, exactly this, teaching sound synthesis, fundamentals, basically, on the Raspberry Pi. And I'm going to walk you through why we did it and why we chose the Raspberry Pi and why we chose the systems that we use. Okay. So mainly our goals, or our outline, was to, well, yeah, enable the students to work on a free system and teach them how to write standalone real-time applications. And that's obviously not so easy, because people have different backgrounds all over the place and not necessarily all come from, well, the computer sciences, or especially in our faculty, it's a broad mixture of backgrounds in mathematics, social sciences, and acoustics. So it's quite a broad thing to gap, basically. Yeah, we wanted to teach on algorithms and sample-wise signal processing and really go on a low level, basically. And yeah, I mean, it soon becomes apparent that most of the tools we use in the faculty are not really applicable. That is stuff like MATLAB or Octave. I mean, it's widely used in that field, but it's not really applicable for any low-level audio, and especially not real-time. So yeah, C and C++ was basically the most reasonable low-level access, you could say. Yeah, so there are some alternatives. I already mentioned MATLAB and Octave that are sometimes used. Juice was not chosen by us because we didn't really have any experience with the framework, so for us it wouldn't have made any sense, basically, at that point. Yeah, and PD, Maximum Speed Supercollider, are kind of too high level for that, what we wanted to achieve with it, basically. We could also go for PD externals, I guess, but that's a whole different thing, and we didn't want to get stuck on just one system, basically. Well, there's also FOST, but both of us don't have a background in functional programming, so that doesn't make sense either for us to teach it. That's why we opted for using JAG. Mainly also because we have some software like Wonder and the Soundscape renderer that was mentioned earlier that we use in our faculty, mainly for doing listening tests and psychoacoustic measurements. So yeah, JAG is kind of the de facto standard, you could say, especially because now it's cross-platform. And basically, we try to have a unified approach, so every student and every group would have the same well, starting point in a way, apart from their own background, obviously. Bela proved to be a bit too expensive for 10 groups, so we didn't have the funds to do that. We might dive into that in the future. So yeah, the Raspberry Pi 3 was reasonably cheap, extensible, and that's why we chose it, because we basically could go for 10 systems for 70 euros each. That's quite okay. As I have mainly a background in Arch Linux and building stuff on Arch Linux, we went for Arch Linux ARM, mainly because we had some incompatibilities with some of the libraries we wanted to use. We needed some newer versions of them, sometimes Git versions that were not available as packages because we wanted to use features that were not available yet. Yeah, with Arch Linux you basically have the nice tools of the nice backgrounds of having Pacman as a package manager. So well, for me that's basically a really nice tool to use, and I really like building packages with it. It's yeah, I don't know, for me at least, an easier workflow. So mainly that's also one of the reasons, I guess, why we chose it. I did some low latency setups, not for ARM systems, but 2 years ago I had a talk on that during the LAC in Mainz. That was about these basic setups using systemd on Arch Linux and starting Jack and yeah, introducing low latency by setting up proper IRQ scheduling. So basically what we did is use the standard image that Arch Linux ARM provides and modified it, tweaked it in the way that we needed it to run, basically. Arch Linux ARM is, much like Arch Linux itself, quite bare bones, so there's not much pre-configured. It's not like Raspbian in that regard. I definitely installed some graphical user interfaces and all that stuff, but it was not really needed in the course of this course in a way. So we went for these libraries that basically enabled us to do all the plumbing we wanted, and we went for RT MIDI because it proved to be more stable than anything else we could use in that regard. And we wanted to enable the students to have a kind of a lo-fi system that is just pluggable with USB and have a USB-driven user experience, basically. Some used Liblo for OSC. That was not so widely used. I think only one group used it in the end, although it's not that hard to implement, I think. But then again, it really depends on what your background is, and not all groups started out with the same background, obviously. Then, yeah, libsoundfile was used for the access of audio files and reading out of audio files. Sometimes needed, not for all projects, so it really depended on what the students wanted to do. Just as my other setups, I use systemd to start Jack. And in this regard, I guess it doesn't really make sense to include the real-time settings because it's not on a real-time kernel either. So it's a bit tricky to really find good settings. All in all, I can say that we did not use the internal audio card, obviously, because that's just too I/O prone, actually, error prone. So we had a USB audio interface that we used that was included in the price as well. Some students that basically were above the limit of what we could provide, they just brought their own and provided their own USB MIDI interface and USB audio interface. And oh, yeah, there's a 0 missing. I just see. I hope you're not running it this way. Please don't. Then we also gave some introductory on how to start the projects that the students were working on, because obviously, like any good startup script that you want to have it started in the correct order, and in this case, Jack needs to be started. Depending on which Jack setup you use, you would have to basically start whatever comes, whatever project you're working on after the Jack service. And this is all enabled because we use the standard user that we created for the system and start its user session automatically. So whenever the Pi starts, the user session of that user is started, so the whole user services that the user has basically are started with it in the order that is needed. Henrik then provided some ready-to-run examples in the repository that we have for the course. Well, then elaborated further in class basically on some examples that basically are mainly focusing on process recording, oscillators, additive synthesis, spectral modeling, physical modeling. There was some abstract example about FM synthesis as well. And students could basically choose from what they would like to do with it, given the tool set that we now provided. And we lent a bunch of USB MIDI interfaces that we have in the faculty, and so people without USB MIDI interfaces could just start working on something that they wanted to do. Obviously, because not always all of them have a Linux background, we had to do some examples and course work on how to use it actually, because that's the main issue, I think. So there was some time spent on explaining how to use a terminal, how to use SSH to connect to your Pi, how to find your Pi in the network, and it's not so trivial sometimes, especially if you use it in your own faculty's Wi-Fi, and then the Wi-Fi craps out because you have like 40 people all connecting wildly all over the place and try to run X applications over the network, and at some point, your Wi-Fi just doesn't want to do it anymore. But yeah, we gave some examples on how to start the jack and the product, how to do the how the DHCP networking is done basically. We have a standard setup that is automatically getting an IP over Ethernet, and Wi-Fi can be connected through WPA supplicant. And some basic other tools to just find your USB audio devices with ALSA, and then how to compile your code on it if you have never done it with a command line and only through an IDE or something like that. So this basically led to a bunch of projects, and some of them are really interesting. I hope I can show this one later if the Pi doesn't crap out in the meantime. They have been working on basically a joystick control. I don't have the joystick with me, so we can only listen to the notes, unfortunately, but it does some really nice morphing, so if you want to try it, all of the code is available. You can put it on your Pi, and it has some really minimal dependencies, just jack and ALSA basically, and the basic libraries that were mentioned earlier. And so this one's even polyphonic, which is quite nice. Not all managed to do that. Some did a digital string waveguide, and according to the Carpus Strong. And this one I can't show though, because I don't have the excitation stuff with me. So, there's some really nice stuff that people worked on. We have this one here, which is also very interesting filter design. Actually, is very fast. That I can definitely recommend to have a look at if you have the time. And this group used I2C or I2C to manipulate the filter. And some of the projects, like this, for instance, it was more focused on getting the hardware to run, or extending the hardware by something that we hadn't provided, basically. And in this case, it was I2C. But we also had, no, that was the one after that, I think. And yeah, the extension is also something that we really are happy about, because this is something that we have not really anticipated, kind of, that people obviously will always get the tool set and then make something out of it, but it's rarely in the constraint that we give them. So, and as this tool set is quite loose, it's quite big, people chose to do a lot of very interesting things with it. Like this one, for instance, where you have a CQT that was generated with a MATLAB script. This is quite big, so if you download the or clone the repository, it's like 150 MB or something. They, for instance, ran into big problems actually getting sufficient I/O out of the Raspberry Pi, because they had to load a lot of tables into RAM to use them later on with the MIDI. Which also, leads to it not being able to do too many notes at the same time, because you generate a lot of sinoids from just pressing one button. Yeah, this one is also quite bare, but it has a lot of compatibilities with all sorts of things. You can hook it up with OSC and MIDI. Unfortunately, I couldn't get it to work. I'm not sure why, but I think the MIDI keyboard that I have doesn't work with their code, so I would have to really investigate and check why that is. I think they used a specific device that they bound this to. This is a very interesting project nonetheless, because you can do all the settings via OSC. That's quite nice. This, however, is more on the practical side, as in these guys really took some hard plumbing to the Raspberry Pi, because they basically extended the whole idea of us doing something like that on a Raspberry Pi to, why don't we do this and create a system that is really just doing audio, and that really real time and super fast. So they started building this tutorial for Buildroot. So you can basically have a dedicated system that only runs a single purpose, basically, it's a single purpose system. This, however, does prove to be quite complicated too. So if you want to go down that road and really have a single purpose Pi, definitely make sure to be able to spend some time on it, and it's you need a lot of testing too to really make it work properly. So we have a lot of different backgrounds, as I said. I mean, this is a recap, and we were trying to attract as many different people as possible, basically, to the whole course. Although we still attracted a lot of Linux users. There are still some Windows users that stuck with us, which is nice to see. They had to use PuTTY and so on and so forth to really connect, and I guess for some of them it was really hard to get into coding on the Pi, because they don't have the background in using terminal too much. And for us, that is basically one thing we have to change. As you can see, a lot of people go really low level and use Vim on the Pi. That was nice to see. But we also have some faculty members that work for big audio companies in Berlin, so they are more confident with working with Visual Studio to actually work on larger scale projects in their company. So they use that instead, also for debugging, which leads me to the next point. That's basically all people did for debugging, and that's really not so nice for us, basically, because if you have an integrated IDE like Visual Studio, that's okay. That's really nice to use. I guess for debugging, you can set breakpoints in a GUI, and it's a bit easier and user-friendly. But many of them, stuck to just plain printouts of whatever they did. And I guess that's something we didn't anticipate either in the beginning. We basically left it open how to start Jack. I mean, my way of starting Jack is just one way. You can start Jack however you want, basically. And mine is just one of the ways for integrated startup because it does it automatically if you're lucky. Many of them, however, felt more comfortable using it in a graphical interface, QJack control, or using a DIY script for starting Jack and some dependencies. We use this Rankforce USB audio card that is really cheap. It's like around 10 euros or so. It's one of these, you can get them all everywhere, kind of USB cards. Some of them work really well, and you can get quite low latencies out of them. Others, not so much. So it's a tryout. If you want to work on a USB audio, make sure to buy several and try them out before you buy a bunch of them, because some of them do not work at all, and they crap out super hard. That's basically 3 that the other groups used that we didn't provide with anything. Obviously, yeah, bigger USB audio cards also work, like the Focusrite Scarlett, as long as it's class compliant, I guess. Yeah, and obviously people had a lot of problems and complaints about what we did and what we provided. There was a bunch of really hard Jack fails due to we don't know what. Sometimes just during startup, Jack wouldn't initialize the sound card, or would just die during playback for no apparent reason. And then you had to restart because it just didn't restart on its own anymore. Or you couldn't restart the service or or the PID, basically. And file input-output obviously is a big problem. So if you want to read in huge tables of data, then you better work around that. The CQT project, they definitely did that, and I found a way to write chunks instead of reading the whole data into RAM in one go, because that apparently is too slow. There's some performance limitations, obviously, that you have to be aware of if you do a project on it, and basically it always comes down to project optimization that you have to do. The problem is just that some people without the background, they are not able to do it. So you definitely have to keep that in mind if you want to provide something like this, that you will have to do some optimization for the project, and all of them are kind of doing things differently a little bit. For most people, it was really hard to debug, obviously. If you don't build a cross-platform project that you can use on any operating system, then it gets really hard to debug sometimes. Sometimes you run into weird, obscure errors due to the libraries that we used. I think one group had this obscure issue with FFTW that did some optimization that didn't work on ARM, and it just crashed horribly, and it was really hard to debug for them, and that obviously eats a lot of time. Most of these packages, they're not really built with certain flags just for ARM, or they're not even optimized for ARM, so that always has to be kept in mind, that if you use these libraries, they might not work as intended sometimes. This is a nice chart. So if you have the terminal versus the visual usage of the groups that we, at least that provided information about what they did, many of them really used the terminal a lot to actually do stuff on the Pi, start things on the Pi, and didn't use X forwarding for it. But as you can see, with how much time was spent on the environment versus the project itself, sometimes that varies a lot, and really depends on what their background is. If someone is not very comfortable with the terminal, then sometimes that leads to just spending some time and learning that, basically. And that's definitely, this side is something that we want to lower a lot, and to make it more easy for people to actually use it. But yeah, for us it was a first tryout, basically, for this project. These are some improvement suggestions by the groups that we got to get easier networking setups. That's obviously one thing, but there's always this trade-off of either doing an access point that eats then a lot of CPU cycles if you're unlucky, if you do a Wi-Fi access point on the Pi, or if you just let it grab the IPs from the network instead. There's a huge difference in I/O, definitely. So we went for the passive approach. We went for having the Pi connect to networks instead of being the provider of the network, which definitely makes more sense, I think, but it's also not the easier way for people to use it. That's the downside, basically. On some operating systems, it's just not that easy to provide a network over Ethernet, so that's a bit painful sometimes. People were demanding less low-level audio MIDI input-output course instructions, but I guess that's what we especially went for, and that's something that I guess makes the Pi also something you can really learn about a system. Nonetheless, we definitely have to work on a more reliable setup. We still have these weird issues of jack not starting, or because it is plugged into one of the USB ports and not the other, and then it just doesn't start for some reason. You restart it a bunch of times and then it does. It's just some weird black magic sometimes with the hardware that is very strange. We were thinking about getting into real-time optimization, but I have not really done that. So if anyone has done it on the Pi, please let me know. And if that's even possible. Sorry?
You can compile real-time kernel, but
it's not worth the effort, yeah, probably. Probably not, yeah, that's one of the things. So you would have to work around many of the issues that you have without it.
But even a non-real-time kernel should be able to do real-time trace.
Sorry?
Even a standard kernel can run real-time.
Yeah, that's true. You don't have the preempt.
It's space to run jack in real-time.
Yeah, that's true.
Absolutely.
Nonetheless, people were demanding more relevant C++ examples, and that's also what we found we kind of lacked, because for us, it's always something. If you know a language, then, or you at least worked in a language for a little bit, then it's for you. You don't see the slope that someone has to take when they come from a scripting language like MATLAB or anything like that, and for them it's just a pain to work that out, and but it's hard to see that when you're on the other side of things. So yeah, that's something we definitely have to improve. Nonetheless, I think the setup was very versatile. We had a lot of very interesting projects. It's too numerous to really show them, actually, and also some of them too complicated to show them properly. We want to test more of the cheap USB sound cards, because these often go out of stock very fast and then they're just gone. And in the future we're going to do some tryout with Bela as well, but we didn't have the sufficient funds to basically have that for as many groups as we wanted to provide for. And yeah. I guess that also leads us to us spending more time on showing people how to debug things on the Pi, how to use GDB, for instance, and or use their own integrated solutions that they are working with. The audio configuration and the pre-setup can be way better, I think, and can be improved a lot. We basically try to have numerous setups that people can try and see how it works with their application, because some applications are just not as demanding, and then you don't need a very high buffer size or whatever, and that's with Jack. Yeah, we definitely have to elaborate more on the C++ programming examples. You can have a look at them in the repository online. All the stuff will be still online for the coming years, I hope. And yeah, show people how to monitor stuff properly. Many people always, I think, especially coming from Windows and macOS, they rarely spend time on monitoring what they do or what the application is doing or what Jack is doing. And if you see what Jack or your application is outputting actually, then that might prove quite helpful most of the time if you find the bottleneck instead of just never finding it and just scratching your head all day. So yeah, if there are any questions, you can write to me on IRC or write an email, either to me or to Henrik. And yeah, is there any questions? Yes. Sorry? Oh, you get a microphone. Wait a second.
Okay, so you have finished?
Yeah, I'm through.
Okay.
Thanks. I can show a short example with some of the projects, though, but yeah, in a bit. First questions, please.
So I think you providing this kind of course more than once.
I hope,
to different kind of people. And what was the typical group size, and what do you think the optimal group size is for this course, and why, and what happens if there are too few people or too many?
Well, our group size was limited to 2, mainly because I guess it gets just quite messy when you start using one system with too many people, I guess. Also, you definitely should at least have 2 people, otherwise sharing of backgrounds is not possible. But I guess if you go above 3 in one group, it gets too crowded, I think, and 2 is definitely a good group size, in my opinion. Yeah.
Hello? Okay. Sorry if I lost you there, but did you, the examples you presented were mostly synthesis examples and not real-time processing examples, like with audio inputs and physical audio inputs and everything.
Sorry, I didn't get the rest.
With physical input?
Yeah. Or physical input as well. Some of them did the resynthesis of the guitar. Maybe I didn't mention that in here. It was... It was too far. Where is it? Maybe I skipped this one? I'm not sure. Maybe it's not in here, I'm sorry. There's one with input. Actually, 2 of them have inputs where you... here.
Okay.
Where you can have at least convolution setups. But you can also input your own guitar sound, basically, if you want to.
But plug it in or as a file?
Sorry?
This I didn't get. Plug it in or as a file?
Oh, both. Both is possible,
okay.
Yeah.
Because
they used, at least during presentation, they used a file because it was easier than dragging your guitar and so on and setting that up. But that also works, apparently. Yeah.
Thanks for the talk.
Yeah.
So basically, I see here that you did some misadvertisement or something like this.
Misadvertisement?
I'm not criticizing you. So you promised your students to learn something about sound synthesis in C++, and what they were doing was fighting with the hard case of reality. So fighting all the system problems.
Yeah,
and
sometimes.
I think these lessons that they learned were very valuable. So I would rather hire someone who had solved all of these problems than someone who had had learned some sound synthesis with a system where everything was already solved and he just has to implement some signal processing code.
Yeah.
So I was wondering, maybe some course like this could be offered in a university, but with a different label. So do you have an idea for that?
A different label, or well, I think it's a bit hard to say. I mean, for us, it was also the first time to do this type of course, and we definitely learned a lot about it. And you can never really, watch out for all the backgrounds that you get, basically. Especially in our faculty, it's quite a variety. It's not a computer science background natively, all of them, but it's really all over the place. So you definitely have to go for a very broad approach. That's what we tried, and I think for us it was definitely also a learning experience, and we tried to improve it a lot because we feel that in some parts it lacked definitely, that there was just too much time spent on the system itself or trying to understand the problems. But then again, sometimes, you run into problems that you wouldn't expect at all, and that can happen on any operating system, I'm sure. Even on a native 64-bit system.
Okay, so no other question. So thanks again, David.
Yeah, you're welcome, thanks. I have a short, I hope, sound example of the vector synth, if you want to. It's this one. Unfortunately, I cannot show the morphing. That's too bad, but yeah. Well, as you see, it's kind of nice. It has a nice overhand sustain. If you go to the lower octaves, it goes quite noisy. Yeah, and that's just one of the examples that basically was implemented. And if you want to have a look, it should build on any Raspberry as well as whatever Raspberry Pi operating system you're using, basically, apart from Windows, I guess. But if you have any questions, I'm around here, and I'd be happy to talk some more about it.
Okay, thanks again.
Yeah.